Question 5 from the C1 paper from Jan05, isn't it? Okay. The diagram is an open-top water tank, horizontal rectangular base and 4 vertical sides. The base has width x. So let me just put this on. Base has width x, length 2x meters, and height h. Okay. So it also tells us that the combined surface area of the base and the 4 vertical sides is 54 meters squared. So I'm going to use S for surface area, I think. Is that okay? So the surface area, S, it tells us is 54 meters squared. Okay. So first of all, the question on the paper says show that x squared plus 3xh equals 27. Well, what we're going to do, I think, is rather than go through it, because it's like an example, rather than go through it and go through the questions as it is on the paper, I'll just go through it in a general way of solving the problem. And they're usually sort of like this. And you'll see where you pick up the marks and things like this. So if you're given a real life question like this to optimize, so this one here is you want to make a box. Essentially the problem is you want to make a box and you want it to hold a certain volume, or you want it to have a certain surface area. How does that affect the volume? Okay, now usually you want to, the basic idea is you want a box to hold a certain volume, and so you want to minimize the surface area, because the surface area is what it's made out of. Okay, so it could be made out of cardboard or paper, and you want it to hold a certain amount, but you want to use the least amount of material to make the box. Does that make sense? Okay, so the first thing you would do with any question like this one's just a box, you want to write down an equation for the volume and an equation for the surface area, because it's usually those two that you're working with. So the volume of this box, can someone tell me how I could write down the volume of this box? How do you work out the volume of a cuboid like that? Base times height times width, yeah? So it's just going to be what? 2x squared h. Brilliant. Okay. And what about the surface area? I know we've already know what the surface area equals as a value, but can I write it down as an expression? The surface area of this box is going to be the area of all the faces. But remember, there's not a face on the top, it's open top. So if I just look at the front face, so this face here, that's got an area of x times h. Okay? And also the face opposite it on the back has also got an area of x times h. Okay? So that means that there must be 2 faces with an area of xh, so 2xh. Let's have a look at this face. The area of that face there is going to be, sorry, well, I've made a mistake, haven't I? That face is 2x times h, isn't it? Oh yeah, okay, so this face is an area of 2xh, and there's 2 of them, so that's 4xh in total, is that right? Cool, I thought I'd made a mistake for a second. Okay, and then finally we've got the area of the base. And the base is just x times 2x, so that's 2x squared. Okay? Is that okay? So 2x squared. And if I tidy all this up, I'll get 6xh plus 2x squared is the surface area. Okay, cool. So the question, so basically I'm ready to start the question now. I've got an equation for the volume, I've got an equation for the surface area, and I also know the value of the surface area. It says that, part A says, show that x squared plus 3xh equals 27. Can someone talk me through how I could do that then? Show that x squared plus 3xh equals 27. Yeah. Yeah, so I've got this expression for the surface area. So this is part A. The surface area is equal to 6xh plus 2x squared, but we also know that the surface area is 54, and so what you're saying, just halve it. Okay, if you just halve it, yeah, you get x squared plus 3xh equals 27, and that's your 2 marks. That's all you had to do. Okay. Next question says, can you express h in terms of x? Can I write down h equals and then only have x and numbers around that? Can someone do that for me? Can I write down x equals just up in h? Is this you again, Ellie?
Yeah.
Okay, go on. Brill. So this is AII. So taking the same equation and just bringing stuff over. 3xh equals what? 27 over x squared. Oh, sorry, yeah. Jeez. Yeah, 27 minus x squared, yeah. Yeah. Sorry. Just need a cup of coffee or something. Minus x squared, yeah. Okay. Yeah, so h must then equal 27 minus x squared over 3x. Is that right? Okay. Is that h in terms of x? Yeah, it is, yeah. It's just got x's in. Okay, so that's A and II, and that's just one mark. And then finally it says, hence show that the volume of the tank can be given by V equals 18x minus 2x cubed divided by 8. Well, we've got an equation for the volume up here, V equals 2x squared h. Yeah, so the equation we've got for volume is 2x squared h. So the equation they've got hasn't got h in, so we just take the h that we've just found and we sub it in. So for part 3, the equation we had was that V equaled, what was it, 2x squared h? 2x squared h, but we know that h equals this, so V equals 2x squared multiplied by 27 minus x squared of 3x, like that. And now I've just got to multiply this out and try and make it look like what's on the sheet. So what could I do? Shall we shall I just multiply the brackets by 2x squared? Should we just go straight in and do that? So what am I going to get? I'm going to get 2 times 27, is that 54? So I'm going to get 54x squared, because I've times 27 by 2x squared. I'm going to get minus 2x to the power of 4, and that's all divided by 3x. Do you agree with that? Say again?
So you're not going to try to express that as 3x and 1?
No. Yeah, you just multiply. If I'm multiplying a fraction by just by 2x squared, so I just times the top. If I times the top and the bottom, for example, if I had a fraction that times the top by 2 and the bottom by 2, I would end up with the same fraction. Do you agree with that? Yeah. If I had a half and I times the top by 2, I'd get 2. I times the bottom by 2, I'd get 4. So it'd be 2 over 4, which is still a half. So just times the tops. Okay. And now we just need to tidy it up a little bit. What might be a good idea is to just write this as 2 separate fractions, which I can do. 54x squared over 3x. Take away 2x to the 4 over 3x. And you should see that I can start cancelling things down. I can take an x off the top here and an x off the bottom. And I can do 54 divided by 3. That's 54 divided by 3. 18. And there's one x left on the top, so it's 18x. And then over here I can cancel an x off the bottom and then an x off the top. And so I just get 2/3 minus 2/3 x cubed, which is what you're trying to show. Okay, and that's okay. Right, any questions up to there? We've done all of part A now. Okay, so what we've got is an expression, the volume, in terms of x, and I could actually plot a graph of that. I could plot that graph. I could put V up the y-axis, I could put x across the x-axis, and we would have a graph that changed. The volume would change dependent on the x, and it might have some maximum and it might have some minimum points in. Okay, so if I want to find out the maximum volume that I can have with this surface area, then how would I do it? How do you find maximum and minimum? Anybody? The second differentiation just tells you what sort it is, but how would I find out if something were... I differentiate it, because the differentiation is the gradient, and when it's at a maximum or a minimum point, then the gradient there is 0. So the idea is I'm going to differentiate that, dv dx, whatever I get, I put it equal to 0, and I find out where the gradient is 0, and then I will try and determine whether it's a maximum or a minimum point. So the next thing I'm going to do is I'm going to differentiate this. This is part B. So BI. It's asking you, notice how the question is just asking you to do one thing at a time, but it's like the way you would solve this sort of problem. So who can differentiate it? Tom, do you want to have a go at this?
18
Yeah.
minus 6x squared over 3.
Yeah, I totally agree with that, yeah. Minus 6x squared over 3. Brill. Okay. Yeah, and that's the same as 18 minus 2x cubed, 2x squared. Yeah. Okay, fine. Okay, so that's your differentiation. That's your 2 marks because you have to differentiate 2 things. Next bit says verify that it's stationary when x equals 3. Well, that's basically saying now put it equal to 0 and solve it. It's stationary, so you want to really on your exam you want to write down this statement at this point. It's stationary when dv dx equals 0. So you want to write that down if you can. Okay, it's got a maximum or a minimum when the gradient is 0. So what we do is we take this gradient that we just worked out, 18 minus 2x squared, put it equal to 0, and we solve it. Well, if it's 18 minus 2x squared equals 0, then 2x squared must equal 18, x squared must equal 9, and so x, what does x equal? 3 or minus 3, isn't it? Okay, so plus or minus 3. So have we verified that there's a stationary point when x equals 3? Yeah, so we could put a statement, therefore stationary when x equals 3. Now, we're talking about a real problem here. We're talking about a length of a side of a box. So the other answer we've got, the minus 3, does that mean anything? Or can we just get rid of that, really, can't we? It's not going to be a negative length. So we're only worried about the x equals 3. So now we need to determine whether this means it's a maximum or a minimum. So how do we do that? That's what you were talking about before, Ella. So, yeah, if you want to determine whether it's a maximum or minimum, then you differentiate again. So this is part C. And when we want to find dv, d2v dx squared like that. And so we're going to differentiate it again. Seb, do you want to do that? So we're differentiating that there. It's just minus 4x. So that's the second differentiation. And when x equals 2, when x equals 3, the second differentiation equals minus 4 times 3, which is negative 12. Okay? And then you need a statement like this. Some of you guys on your mark didn't put this. This one involves a lot of statements. So you have to say it's stationary when it equals 0, and you will also have to say this: d2v dx squared is less than 0 in this case, which means what? So it's a maximum. So come to that in a second. So it's a maximum.